My name is Jordan Hernandez, and today I'll be going into Demo 2 Learning Target 4B. So, what is Learning Target 4B about? 4B, I can translate between algebraic expressions, truth tables, and logic circuits. And what this means is that I could basically convert from algebraic expressions to the truth tables, and then I can apply that to any circuit diagram. So an example we'll have for today is from algebraic expression to a truth table. So we have our equation q equals a prime b prime c plus a prime bc plus ab prime c plus abc prime plus abc. And one of the shortcut ways is that since this is a CSLP in equation, that means it's going to be a min term on the truth table, which is equal to 1. So all we have to do is that we have to make this multiplication equal to a 1. So when we have a prime b prime c, it's going to be 0 times, or it has to be 0 times 0 times 1, because that would equal to our equation of 1, because these will be turned into 1 with the primes. Same thing could be applied down here with a prime bc, so 0, 1, 1 equals to 1 again. ab prime c equals to 101. ABC primes 110 equal to 1. ABC will just be equal to triple ones equal to 1. So once we have that all applied, I put these elements into the side, and I've made my truth table. Our inputs are going to be ABC as represented as part of our equation, which is right here, and then our output's going to be Q, which is where we're basically going to equal to zeros and ones. And I have it all lined up. So when I plug all these in for 001, 011, 101, 110, and 111 are going to be all ones on the truth table, and the rest are going to be 0, which look like this. Now, the same way could be applied for truth table to an algebraic expression too. So let's say if I want to find CPOS, I can basically know that CPOS is going to be in max terms, which are going to be in 0 output. So the only ones that have 0 outputs are going to be these three right here. So we got A plus B plus C, which we have it right here, is going to be 0, 0, 0, which is equal to 0. For this one, since it's 0, 1, 0 is equal to 0, we're going to have to know that the 1's going to be a prime since we want it to equal to 0 in the end of this addition problem. And the same thing applies to 1, 0, 0. A prime plus B prime plus C equals 1, 0, 0 equals 0. So we can have our full equation of Q equals A plus B plus C times A plus B prime C times A prime plus B plus C. For the table to circuits, let's say we're going to start off with our equation being the truth table. And then once we found out our truth table, we can have our algebraic expression. Since this was an algebraic expression from the previous demo, we know that when it's simplified, it equals to Q equals AB plus C. And either way, you can have it simplified, but I prefer when making circuits, I want to make the expression be more simplified so that the circuit could be more understandable. To which the circuit will look like this. We have ABC as our inputs, and then Q being our output. And then we have one AND gate and one OR gate. And how this represents as an equation, we can look at it like this. So I'll use an example from a circuit to a truth table, since it would have to require 2 steps to understand. So we got A, B, C, and there's 2 ways you can do this. You can either input it in order for the truth table, or you can solve it too by finding out the equation for it. So we have these 3 AND gates with the NOT gates being representing as the primes, so we can know that this would equal all to A plus B plus C, which is this first gate, A plus B prime plus C in the second gate, A prime plus B plus C in the third one, And then our last AND gate right here is going to represent the whole entire equation, with Q being our output. So when we can plug it back in, you can see that it reflects back to our truth table at the beginning. So, and then 0 is always going to represent as max terms in this equation. This is the ending of Learning Target 4B. I hope you all enjoy.